In this video, we are going to see about the chapter electricity. Here, first we are going to see what is an electric charge. So here, an electric charge is a physical entity. Okay, it is defined as the amount of electricity contained in an object. So it may be excess or deficiency of electrons. Here, this electric charge can be of two types. That is, it may be a positive charge or a negative charge. Here there are two important properties for the electric charge. So the two important properties for this electric charge are the like charges. If the both charges are same, they can repel each other, and unlike charges can attract each other. So these are the two important properties for this electric charge. So here next we are going to see the unit of electric charge. The SI unit of electric charge is measured in coulombs. Okay, here this charge is denoted by the letter Q. So Q of the body is given by Q is equal to N into E. So here Q is the product of number of electrons, and E is the charge on a single electron. So it is the product of the number of electrons and the charge on a single electron. So the charge on a single electron is approximately 1.6 into 10 power minus 19 coulombs. This value is a fundamental constant in physics. Next, we already know that the atom is made up of protons, neutrons and electrons. These protons are positive charge, electrons are negative charge, and these neutrons, they have no charge in them. So next is the electric current. Here this electric current is the flow of electric charges in a conductor. So it is expressed as the amount of charge flowing through a particular area. So it may be a particular area in a unit time. So it is the amount of electric charge flowing in the body. So it is denoted by the letter I. So I is equal to Q by T. So here Q is nothing but it's the electric charge that flows in a particular time. So T is time. So I is equal to Q by T. So it is equal to the amount of electric charge divided by the time taken to flow. Okay. So this electric current is measured by an instrument called ammeter. Next, we are going to see the ammeter. This ammeter is a measuring instrument. Okay, it is used to measure the electric current in a circuit. So here the electric currents are measured in amperes. So it is denoted with the letter A. Okay, here we already know that electric current is equal to electric charge by time. So 1 ampere is equal to 1 coulomb by 1 second. Okay, and then ammeter should always have a very low resistance so that it may not change the value of the current flowing in a particular circuit. Electric potential. So electric potential at a point is the work done per unit charge in bringing a charge from infinity to that point. So it is given by a formula V is equal to W by Q. So here V is denoted as the electric potential, W as the work done and Q as the charge. So here the electric current will flow through a conductor only if there is a difference in the electric potential between the two ends of the conductor. So the difference in electric potential, this is called the potential difference. So it is nothing but the potential difference between 2 points in an electric circuit is defined as the work done to move the unit electric charge from one point to another in an electric circuit. So it is provided by a cell or a battery. So this sets the electron in motion and thus produce the electric current. Let's see the potential difference with an example. Okay, here it is taken for 2 points, that is A and B. It is like how we are measuring how much work is needed to move a tiny electric charge from point B to point A. So here they have mathematically represented, that is the potential difference is taken as V. It is expressed as the difference between the potentials of point A and point B. So it is given as work done by the charge move. So here the potential difference is measured in terms of volt. The work done is measured in terms of joule and the charge is measured in terms of 1 coulomb. Okay, so it can also be written as 1V by 1J by 1C. Okay, so the SI unit of potential difference is volt V. So here it is measured by an instrument called voltmeter. So it is always connected in parallel across the 2 points between which the potential difference is to be measured. So voltmeter is a measuring instrument. This is used for measuring the electrical potential difference between 2 points in an electric circuit. So this voltmeter always has a high resistance. Okay, so it always take a negligible amount of current. Electric circuit. So it is a continuous and closed path of a electric current. So it is a diagram for electric circuit. It contains a cell, a electric bulb, ammeter and a key. Okay, here the electric current is measured with the help of ammeter. This ammeter instrument is connected in series in a electric circuit. Here there are some symbols that we use in the electric circuit diagram. So please have a look. Ohm's law. So this Ohm's law is a relationship between the potential difference across a conductor and the current flowing through it. So here this Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference between its ends provided its temperature remains constant. So here, so it says that if electric current increases, the potential difference increases. So if electric current decreases, the potential difference decreases. Okay. So according to Ohm's law, the potential difference is directly proportional to the electric current. So here V is the potential difference, I is the electric current. So it can be written as V is equal to R into I. So R is nothing but it is the constant resistance of the conductor. So it can be written as I is equal to V by R. So current is equal to I is equal to V by R. And resistance is equal to potential difference by current. Okay, so R is equal to V by I. So here the current is directly proportional to the potential difference. The current is inversely proportional to the resistance. Resistance is nothing but it is a property of conductor due to which it opposes the flow of current through it. Okay, this is because the resistance is inversely proportional to the current. As per Ohm's law, resistance is always a constant. Okay, so it is calculated as potential difference by current. Okay, here the SI unit of resistance is measured in ohm. This is the ohm symbol. Okay, if the potential difference across the two ends of a wire is 1 volt and the current flowing through it is 1 ampere, then the resistance R of a conductor is 1 ohm. Okay, so here I is given as V by R. Okay, the current flowing through a resistor is inversely proportional to the resistance. Okay, so if the resistance is doubled, then the current gets halved. Factors on which the resistance of a conductor depends. Okay, so here let's see. The first point is it is directly proportional to the length. So the resistance is directly proportional to the length. Next is it is inversely proportional to the area of cross section. So it is inversely proportional to the area of cross section. Next, it depends upon the nature of the material by which it is made. Okay, and it depends on the operating temperature. So these are the factors that the resistance of a conductor depends. Let's see the difference between the conductors and the insulators. Okay, here conductors are nothing but they are the substances that have the property to conduct electricity through them. So this conducts electricity, but this insulators, these are the substances that have the property. They do not have the flow of electricity. So here they cannot conduct the electricity through them. So next, here in conductors, they have free or loosely held electrons which help in conducting electricity. But here they do not have free electrons present in them. So for example, here let's consider copper. This copper is a good conductor. It conducts electricity. But here the insulator, the example is the rubber insulation. So in this given diagram, this copper, it conducts electricity, and this rubber insulation, as this is the insulator, it doesn't conduct electricity. So this is an example for conductors and insulator. The resistors can be combined, okay, in two ways. One, if it is connected in series, and next is the resistors connected in parallel. We're going to see the circuit diagram of the resistors that are connected in series. Here, suppose consider three resistors, that is R1, R2 and R3. They are connected in series across the point A and B. Okay, here the current in all resistors is same. Okay, the total voltage PD across the resistors is equal to the sum of the voltage across the resistors, that is V1, V2 and V3. So this is the total voltage. It is taken across each resistors. Okay, and next is the equivalent resistance is nothing but it is the sum of the R1, R2 and R3. This is to show you that the resistors, if they are connected in series, the diagram will be like this: R1, R2, R3, they are continuously connected. So here the total resistance R is given as R is equal to R1 plus R2 plus R3. So if the resistors are connected in parallel, it will be from top to bottom R1, R2 and R3 between 2 points. Okay, so resistors in parallel, the total resistance of R is equal to, given by 1 by R is equal to, as it is parallel. Okay, so 1 by R1 plus 1 by R2 plus 1 by R3. So here the total resistance is connected in this way. Next, we are going to see if the resistors in a circuit are connected in parallel. So this is the diagram point from A to B where there are three resistors, that is R1, R2 and R3. These resistors are connected in parallel, and here the voltage PD in all resistors will be the same. Okay, the total current in resistor 1 as I1, I2 and I3. For R2, R3, they are calculated as I1, I2 and I3. So it will be taken as the total current as I. And the reciprocal of the equivalent resistance will be the sum of the reciprocals of each resistance. This is for R1, resistor 1, resistor 2 and resistor 3. Difference between the parallel and the series connection. So for parallel connection, if one electric appliance stop working due to some defect, okay, then all other appliances keep working normally. But in series connection, as they are connected with each other, what happens is if one electric appliance stop working due to some defect, then all the appliances stop working. And second point, in parallel circuit, okay, it has its own switch due to which it can be turned on or off independently. So here it acts as independent. But here they all have only one switch, due to which they cannot be turned or on or off separately. Okay. So it depends on each other. Next, third point, each appliance gets same voltage as that of power source. It gets the same voltage, but in series connection or circuit, the appliance do not get the same voltage as that of the power supply line. Okay, next one is the overall resistance of household circuit is reduced. Here it is reduced, due to which the current from power supply is high. In series circuit, the overall resistance increases, due to which the current from the power source is very low. Okay, these are the difference for parallel and series connection. So let's see the difference between the resistors in series and resistors in parallel. So we are going to see for the current, voltage and resistance. Suppose if the resistors in series, the current will be of a same current, it flows through each resistors, but the voltage divides among the resistors, that is the V total voltage is equal to V1 plus V2 plus V3. So next, the resistance is calculated as the sum of the individual resistance. Suppose R1, R2, R3, this will be the sum of the resistance. So when the resistors are parallel, the total current divides among resistors like I1, I2, I3. So the same voltage across each resistors. And for the resistors in parallel, the reciprocal of the total resistance will always be the sum of the reciprocals of the individual resistance. That is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 likewise. Electric power. The rate of doing work is called the power. So here power is given by work done by time. So here this electric power is measured in joules per second. So joules per second. So the rate at which the electric energy is consumed in an electric circuit, that is the power, is equal to VI. So SI unit of power is watt. Okay. So 1 watt is equal to 1 volt into 1 ampere. Okay. So 1 watt is power generated by the electrical device when an electrical appliance is operated at the potential difference of 1 volt and the current 1 ampere flows through it. Next is the heating effect of the electric current. So here, if the current I flows through a resistor of resistance R, then T is the time for which the charge Q flows through it. Then the work done to move the charge through potential difference V is given as W is the work done is equal to charge into potential difference. So here the P is equal to W by T. W is the work done by time. So here is equal to Q into V by T. So here P is given as V into I. So here the according to Ohm's law, we already know that V is equal to I into R. So the heat produced H is measured as I square into R into T. Here are some practical applications of heating effect of electric current that we use in our day-to-day life. It may be electric iron, electric bulb, electric heater, and the electrical fuse.